everyone, and welcome to another math tutorial. In this video, we continue our discussion of chain rule in calculus. We're going to look at chain rule and its uses within trigonometric functions. Now, it is a prerequisite that we do know our basic trig derivative rules. So if you do and you're ready to go, let's continue together. Okay, the first problem, we want to find the derivative of y equals sine of 4x. Now, it's not very common, let's just say, that I'm going to ask you for derivatives of sine x or cosine x or tangent x. And generally, the x is going to be replaced with some other function. We're going to have something more complex here than just simply sine x. So oftentimes with trig functions, you're going to be using chain rule, okay? And so when you see a trig function like this, whatever's inside the parentheses, if parentheses are used, sometimes parentheses aren't used, but it's implied that they're there. But whatever follows the trig function, this is the inner function, okay? That means that the trig function itself is the outer function, okay? So inside the parentheses, again, that's what's on the inside. So when we do our chain rule and we think about the order of how we're going to differentiate the pieces here, you have to start with the outer piece, which means we have to start with the sine, okay? So first thing I'm going to do is I'm going to differentiate sine. Now sine differentiates to cosine. And like we saw in the previous video, when you take the derivative of the outside function, at that time, you leave the inside function as it is. So we're not going to do anything with the 4x yet. Now what we're going to do is multiply by, and this is where we take the derivative of the inside function. So the 4x becomes just 4. And then if you want to clean this up a little bit algebraically, you're going to probably just pull this 4 to the front of cosine and write 4 cosine 4x. Okay, next example, we have y equals cosine of 3x to the fourth. Let's just jump right to the derivative here. Again, the trig function is the outer function. So we're going to start with the derivative of cosine. And the derivative of cosine is negative sine. So we want negative sine. And when I take the derivative of that outer function, the inside function just stays the same. So this is going to be 3x to the fourth. Now we're going to multiply by the derivative of 3x to the fourth. That's a very simple power rule where the power comes out to the front. Gives us 12x to the third. That's it. The calculus is done there. That's our derivative. Most people are going to bring this factor and they're going to move it to the front of the trig function. So you can certainly do that. Make sure you carry that negative all the way out to the front too. So we're going to have negative 12x to the third sine of 3x to the fourth. That's more than likely how you're going to see any solution presented. Okay, next example, we have y equals tangent of 4x plus 5. Again, just like in the last two problems, the trig function is the outer function, and what we see here inside of parentheses, the 4x plus 5, that is our inner function. So we're going to begin this, we can go right to the derivative. The derivative of tangent is secant squared. And when I do that tangent derivative, when I do the outside, again, the inside stays the same. So 4x plus 5, we're not differentiating that yet. And now we're going to multiply by the derivative of 4x plus 5, which is 4. Now again, just like in the last couple of problems, typically the cleanup is we're going to take that 4, that factor, and we're just going to pull it to the front of the trig function. So our derivative is 4 secant squared of 4x plus 5. Okay, the final example of this video, we have y equals secant 8x. Again, like all the other problems, secant is the outer function, it's the trig function, the 8x inside the parentheses, that's the inner function. I wanted to show an example with secant. The same would apply for cosecant because the derivative for chain rule with these two functions sometimes I see will trip up students because the derivative of secant, as we're aware, is secant tangent, is actually two trig functions. And when you do that, you have to carry that inner 8x on both of those trig functions. Okay, so this is what I mean. Let's go ahead and start this. The derivative of secant is secant tangent. All right, we're going to have both of those. Now, whatever is on the inside needs to make sure it stays on the inside. So this 8x actually gets placed into both of these. And now we're going to multiply by the derivative of 8x, which is 8. If you like, then what's very common again is just take that factor, that constant factor, and just move it out to the front. So y prime equals 8 secant 8x tangent 8x. You know, after you do enough of these and you really start to get the hang of it, you're probably able to just skip this step and go right from problem to derivative to answer, because you know the derivative of this inner piece is essentially the only rewrite we're doing is just slipping it in front of the derivative of the outer piece. So once you get the hang of that and you can do that comfortably, it's very natural to probably skip this line right here and just go right to the derivative. Okay, if you have any questions or comments, please leave them down below. I want to thank you for tuning in and watching this video. If you found it helpful, please support the channel by giving the video a thumbs up, and I'll see you in the next one.